So the last thing I want to do then is I want to do a very specific case, and it might start off thinking, why on earth are we trying to do this? But it will start to make sense hopefully next week as well. So what I want to do instead is I want to actually put a number in for A and a different letter in for B. So I'm going to say, right, what happens if I try and expand not A plus B to the power of n, but 1 plus r to the power of n? In other words, I try and expand a binomial where the first term is just 1. Okay? This is what I want to try and come up with. So can you generalize the formula for me? Okay, so now A is equal to 1 and B is equal to r. So what would the first term be? Yeah, it's still n choose 0. And then A is just 1 in this case. So it would just be times 1 to the power of whatever n is. Okay? All right. What's the next term? Yeah, good. N choose 1. I'll still write 1 to the power of n minus 1, but we'll do a bit of simplification on the next step, next round. And then B is just r in this case. Okay. What's the next term going to be? Good. Good. So 1 to the power of n minus 2 times by r squared. What's the next term going to be? So let's go for the r cubed term. Yeah, good. 1 to the power of n minus 3, r to the power of 3. And then we'll just carry on like this until we want to stop at r to the power of n. Okay? But I'm just going to carry it on like this. Now let's go through and do a bit of tidying up. So what's n choose 0? How many different ways are there of choosing no objects from a collection of n? There's just one way. You don't choose any. So it's just equal to 1. What's 1 to the power of n? Just 1. So this first term, would you be happy, is just 1. Okay? All right, plus n choose 1. What's that equal to? It's just n, isn't it? And that's just 1. Yeah, 1 to the power of n minus 1 is n. So we get 1 plus n. Okay, fine. Times r, of course. There's still an r there. Okay. All right, plus, what about this thing? So we can do a bit of tidying up. You're happy you still have the r squared? Okay. You're happy this is still 1? Yeah? Happy this is still 1. I'm just going to write this out slightly. So n choose 2. What would that actually be equal to if I use the formula? Perfect. Okay, and if I do a bit of simplification, are you happy that n factorial would be n multiplied by n minus 1 multiplied by n minus 2, and you carry on going like that? Okay, so in fact, I could write this as n times n minus 1 times n minus 2 factorial, yeah? All divided by 2 factorial, n minus 2 factorial. Ah, look, we get a cancellation. Get a cancellation there and there, okay? So in other words, my coefficient here would be n times by n minus 1, all divided by 2 factorial. You happy with that? Okay. What would the next one be? So what would n choose 3? So you're happy you still get r cubed. You're happy you get still 1. What do you think that coefficient is going to be? So what would n choose 3 be simplified? Yeah, good, because you kind of get the same idea. So you get n minus 2 times n minus 3 divided by 3 factorial n minus 3 factorial. You're happy? I've just cancelled that out, or sorry, expanded that out, just like I did with this one. Okay, I get a cancellation there, and I get a cancellation there, which means that I'm left with, you're dead right, n minus 1, n minus 2 divided by 3 factorial, r to the power of 3. And I would keep going like so. Okay. So what I've done here is a very specific case of my binomial expansion. I've basically said, well, imagine that first number is 1, and I do 1 plus something, whatever it is, raise it to the power of n. This is what it should be equal to. Okay. So what would the next term be? Can you kind of see the pattern here? What would the r to the power of 4 term be? And you get the idea, okay? So effectively all you're doing here is doing n minus 1, n minus 2, n minus 3. You know where to stop with the n minus whatever, because it's always 1 less than whatever your power is, okay? and then you just divide by whatever the power is. Okay? So in general, if I want to find the nth term of this expansion, what would that be? What would the nth term of this expansion be? So this would be a bit easier. N times by n minus 1 times by dot 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 all the way up to n minus k minus 1. That's better. Divided by k factorial and then r to the power of k. So this would be my kth term, if you like, of my expansion. Is that okay? Yeah? So this is kind of like what happens if I take my first term of my binomial expansion being 1, and my second term is r, and then see what happens as I raise it to different powers. This is what this is equal to. And we'll look at this in a bit more detail next week. Okay? But this is effectively a binomial series. You happy why it's a series? Because you're adding terms together. Okay? So you're taking a sequence effectively with something in common, just basically that, and you are adding them all together, therefore you get a binomial series. Okay, so this is my binomial series here, this one here. Okay, so if you take nothing else away from this lesson, take that.